Have you ever stopped to think about what's really behind the AI revolution? It isn't just some magic code floating around in the cloud. Nope. It's actually a story about hardware, incredible hardware. The evolution here is so massive, it's literally changing what we even mean when we say computer. So let's dive in and break down how this whole thing works.
Okay, so this is the core idea, right here. We've got to stop thinking about computer hardware as just, a bunch of parts cobbled together. The new way to see it is as a single, giant organism. And just like any organism, its success, its power, comes down to how well its vital organs can talk to each other. That high-speed communication, that data exchange, it's literally everything. All right, so here's the game plan. First, we're going to meet the power trio that makes all this AI stuff possible. Then, we'll see how each of those players had to evolve. After that, we'll look at how they all connect to form this incredible supersystem, how the lines between them are starting to blur, and finally, we'll peek into the future and this virtuous cycle of innovation. Sound good? Let's go.
All right, let's get into it. First up, AI's high-performance trio. Seriously, if you want to get what's happening in AI hardware, you have to know these three: the CPU, the GPU, and a little something called HBM.
So the best way to think about them is like a super specialized crew. You've got the CPU, that's the brain, the big picture thinker. Then there's the GPU, that's the muscle, doing all the heavy lifting. And then there's high bandwidth memory, HBM for short. Think of it as the circulatory system, It's this incredibly fast type of RAM that just pumps data where it needs to go at unbelievable speeds. And really, the performance of any AI model, whether it's learning or actually doing its job, comes down to one thing: how well these three work together.
But here's the thing. To build that giant organism we talked about, it wasn't enough for each part to just get faster. They had to get smarter too. Every single component needed to evolve, to specialize for the totally insane demands of AI. So let's take a look at how each one of them got a major upgrade.
Okay, first up is the good old CPU. But in the age of AI, it's got a new job title, the orchestrator. And yeah, that means it's not the one doing all the grunt work anymore.
So you can really see the difference here, right? In the past, the CPU was kind of a jack of all trades, a workhorse that tried to do everything. But now it's more like the conductor of an orchestra. Its main job is to manage the whole AI workflow. It uses these really specific new instruction sets. A good example is Intel's AMX, which is designed to speed up matrix math, and its whole goal is to get the data prepped and ready before it passes the baton to the real powerhouse.
And that powerhouse, well, that would be the GPU. It has become the absolute, undisputed heavy lifter in the world of AI. Its job is just one thing: massive, parallel computation, all at once.
The GPU story is actually pretty cool. It got its start making video games look pretty, rendering all those graphics. But it turned out that its whole architecture, the way it's built to do thousands of things at once, was a perfect match for AI. So now, it's this insane accelerator with tens of thousands of specialized cores. And the focus has shifted, It's all about speed and efficiency now. They've even figured out that they can trade a tiny bit of precision by using simpler number formats like FP8 and FP4 to get way more speed and squeeze every last drop of performance out of every watt of electricity.
Okay, so you've got your orchestrator and your heavy lifter. Great team, but what happens if they're just sitting around, starved for data? They're totally useless, right? Well, that's exactly where our third player comes in. Say hello to HBM, the high-speed fuel pipeline.
So here's the paradox. When your GPU gets too fast, it actually creates a brand new problem. We call it the memory wall, and you can see it on the left. The GPU just blitzes through its calculations and then nothing. It just sits there, idle, waiting for the next batch of data. It's a huge bottleneck. HBM completely solves this, and the design is just brilliant. Instead of spreading memory chips out on a board, it stacks them on top of each other, vertically. This creates this super wide, super fast pipeline that just gushes data into the GPU so it never, ever has to wait. Okay, so we've got our specialized components, our dream team. But how do you actually, physically connect them to make that super system we've been talking about? Well, the secret sauce, the real magic, is in something called advanced packaging. And believe me, this is the core challenge right now. When you've got components this fast, the physical space between them, we're talking millimeters here, becomes a massive traffic jam. You get delays, you get signal loss, it's a huge problem. So the question is, how do you solve AI's biggest traffic jam? Well, the answer is a clever bit of tech called CoWoS. That stands for chip on wafer on substrate. So look, on the left, that's the old way. Chips are kind of spread out, taking the local roads. On the right, that's CoWoS.
It puts the GPU and all its HBM right next to each other on this special little piece of silicon called an interposer. You can think of that interposer as their own private multi-lane superhighway. It lets them exchange data at insane speeds and just completely gets rid of that traffic jam.
And this idea of packing things super tightly together, well, it's going even further. We're now seeing this really fascinating trend where the old clear lines between what we call compute, memory, and storage are all starting to get really, really blurry.
For example, check out processing in memory, or PIM. The traditional way, on the left, is honestly kind of wasteful. A ton of energy and time is spent just shuttling data back and forth between the processor and the memory. PIM, on the right, is a total game changer. It asks a simple question: what if we put the calculators inside the storage? It integrates logic right into the memory chips. So now the data gets processed right where it lives. This slashes delays and power usage. And just like that, the boundary between computing and storing, poof, it's gone.
And then you have something called CXL, or Compute Express Link. Think about it like this. Before CXL, every CPU or GPU lived on its own little island with its own private beach of memory. This created all these separate silos, and it really limited how big of a problem you could solve. CXL basically builds a massive bridge connecting all those islands. It creates one giant shared swimming pool of memory that everyone, CPUs, GPUs, you name it, can access. It just completely changes the game for memory capacity and how efficiently you can use your resources.
So you take all this incredible innovation, and where does it all lead? Well, it leads to something the industry is calling a virtuous cycle. Basically, it's this amazing feedback loop where a breakthrough in one area just sparks new breakthroughs in all the others.
Yeah, so the big takeaway here is that the next huge leap forward in AI speed isn't going to come from one single magic bullet. Not at all. It's going to come from this constant reinforcing cycle between three things: better connectivity, new custom chip designs, and, you guessed it, more packaging innovation. Each one just keeps pushing the others to be better. And here's what that cycle actually looks like. First, you have advanced connectivity. That's about fusing memory and logic even closer together. Next comes custom architecture. We're going to see more and more specialized chips, like NPUs, or neural processing units. These things are designed to do just one job, like run a specific AI model, but to do it with mind-blowing efficiency. And finally, tying it all together is packaging innovation. That's where things like 3D stacking become absolutely essential to get all that performance out. So look, if there's one thing to take away, it's this. The game has changed. It's not just about who can make the fastest single chip anymore. The real difference maker, the thing that will define the winners and losers in future AI hardware, is the packaging technology. It's all about how you bring all these amazing specialized pieces together into one seamless, incredibly powerful system.
And that brings us full circle, right back to where we started. We've seen the hardware go from just a box of parts to a single, living, breathing organism. And as all these different pieces continue to melt together, it really makes you think, doesn't it? What's the next great boundary for AI to smash through?